Download this code from codegive.com, link in the description below. OK, let's dive deep into Reactsecurity, focusing on JSON Web Tokens, JWT, and how to securely attach them to Axios requests within a React application. This will be a comprehensive guide, covering various aspects, best practices, and potential pitfalls. Understanding the fundamentals. What is a JSON Web Token, JWT? A JWT is a standard for securely transmitting information as a JSON object. It's commonly used for authentication and authorization. Think of it like a digital passport or an ID card. A JWT consists of three parts. Header contains metadata about the token, such as the algorithm used for signing, example HS256, RS256, and the token type, JWT. Payload contains the claims, statements, about the user or entity. These claims can be registered claims, example ISS, sub, AUD, EXP, public claims, defined by the issuer, or private claims, custom claims specific to your application. Signature ensures the integrity of the token and verifies that it hasn't been tampered with. It's calculated by applying the specified algorithm to the encoded header, encoded payload, and a secret key, or a private key if using asymmetric encryption. Structure header.payload.signature, all base 64 encoded. Why use JWTs? Stateless authentication. The server doesn't need to maintain session state for each user. The JWT contains all the information needed to authenticate the user on each request. This simplifies scaling. Scalability. Because authentication logic is stateless, it is easy to scale up the system to handle more concurrent users. Cross-domain authentication. CORS JWTs work well in scenarios where your API and client application are on different domains. Easy integration. JWTs can be generated and validated on different platforms. Authentication versus authorization. Authentication. Verifying the identity of the user, example confirming their username and password are correct. Who are you? Authorization. Determining what the user is allowed to do, example access certain resources, perform specific actions. What are you allowed to do? Axios, a popular HTTP client. Axios is a promise-based HTTP client for the browser and Node.js. It provides a clean and straightforward API for making HTTP requests. It automatically transforms JSON data, handles request and response interceptors, and supports cancellation. 2. Setting up your React application, example. 1. Create a new React app, if you don't already have one. 2. Install Axios *. 3. Basic folder structure, recommended. 3. Authentication flow, simplified. 1. User logs in *. The user enters their credentials, username/password, on the login page, login.js. 2. Authentication request *. The React application sends the credentials to the authentication server, API endpoint. 3. Server validates credentials *. The server verifies the credentials against its user database. 4. JWT generation *. If the credentials are valid, the server generates a JWT. 5. JWT storage *. The server sends the JWT back to the client, React app. The client stores the JWT securely, more on this later. 6. Subsequent requests *. For subsequent requests that require authentication, The React app includes the JWT in the authorization header of the HTTP request, using Axios. 7. Server verification *. The server receives the request with the JWT, verifies the JWT signature, and extracts the claims from the payload. 8. Authorization *. Based on the claims in the JWT, the server determines if the user is authorized to access the requested resource. 9. Response *. The server sends back the requested data or performs the requested action. 4. Code implementation. *src/services/authservice.js, authentication logic. *src/services/api.js, Axios configuration and JWT attachment. *src/components/login.js. *src/components/profile.js. *src/app.js. V server-side, example using node.js with Express. 1. Install dependencies *. 2. Server.js, simple example. 6. Secure JWT storage and handling. This is critical. Never store JWTs in local storage directly. Generally, while local storage is often used for simplicity in tutorials, it's vulnerable to XSS, cross-site scripting, attacks. If an attacker can inject malicious JavaScript into your page, they can steal the JWT from local storage. Alternatives for storing JWTs *HTTP only cookies *. This is generally considered the most secure option for storing JWTs in the browser. Set the cookie with the HTTP only flag. This prevents JavaScript from accessing the cookie, mitigating XSS risks. The browser automatically sends the cookie with each request to the same domain. Important *. Your API and client application must be on the same domain, or subdomains, for cookies to work. Also, ensure you set the secure flag on the cookie to ensure it's only sent over HTTPS. You also need to be aware of cross-site request forgery, CSRF, attacks. You can use techniques like the double submit cookie pattern or synchronizer tokens to protect against CSRF. Backend, node.js/express example. Frontend, React doesn't directly access the cookie. Axios will automatically send the cookie with requests to the same domain. In-memory storage, context or Redux store the JWT in a React context or Redux store. The token is only available in memory and is cleared when the browser session ends. This is more secure than local storage but still susceptible to XSS attacks if an attacker can access the application's memory. Use this in combination with other security measures. Web workers. Advanced web workers run in a separate thread and have limited access to the main thread's global scope. You can store the JWT in a web worker and use message passing to communicate with the main thread. This adds another layer of protection, but it can increase complexity. Browser's credential management API can be used to store the tokens and manage login sessions safely. This approach can be complex and may not be universally supported. Cookie with anti-CSRF tokens. You can implement a secure solution by using cookies in conjunction with anti-CSRF tokens. The token is embedded in the JWT's payload, and when the client sends a request, it reads this value from the cookie and includes it in the request's headers. The server then verifies that the value in the header matches the cookie's value, enhancing security and preventing CSRF attacks. Securing cookies. HTTP only prevents client-side JavaScript from accessing the cookie, mitigating XSS risks. Secure ensures the cookie is only sent over HTTPS connections, preventing man-in-the-middle attacks. Same site helps prevent CSRF attacks by controlling when cookies are sent with cross-site requests. Use strict or lax depending on your needs. Token refresh JWTs should have a relatively short expiration time, example 1 hour. Implement a refresh token mechanism to obtain a new JWT without requiring the user to re-enter their credentials. The refresh token is typically stored more securely, example in an HTTP-only cookie, and used to request a new JWT from a dedicated refresh token endpoint. 7. Security best practices. Use HTTPS. Always use HTTPS to encrypt communication between the client and server. This protects against eavesdropping and man-in-the-middle attacks. Validate JWTs on the server. Never trust the JWT without verifying its signature on the server. Use a robust JWT library for your server-side language to handle JWT verification. Use strong secrets. The secret key used to sign the JWT should be long, complex, and stored securely, example in environment variables, a hardware security module, HSM, or a secrets management service. Never hard-code secrets in your code. Implement rate limiting. Protect your API endpoints from brute force attacks by implementing rate limiting. Limit the number of requests a user or IP address can make within a given time period. Input validation. Thoroughly validate all user inputs on both the client and server sides. This helps prevent injection attacks, example SQL injection, XSS. Output encoding. Encode data before displaying it to prevent XSS attacks. React automatically escapes variables rendered in JSX, but be careful when using dangerously set inner HTML. Content security policy, CSP. Use CSP to restrict the sources from which the browser can load resources, example scripts, style sheets, images. This can help mitigate XSS attacks. Regularly update dependencies. Keep your React libraries, Axios, and other dependencies up to date to patch security vulnerabilities. Monitor and log. Monitor your application for suspicious activity and log security-related events. This can help you detect and respond to attacks. Principle of least privilege. Grant users only the minimum permissions they need to perform their tasks. Avoid giving unnecessary access to sensitive resources. Secure API endpoints. Authentication is essential, but authorization determines what authenticated users can do. Implement RBAC, role-based access control, or ABAC, attribute-based access control. Throttling and rate limiting. Avoid storing sensitive data inside a JWT directly. 8. Refresh token implementation, example. 1 server-side, node.js/express. 2 client-side, React. 9. Key takeaways. Security is a continuous process, not a one-time fix. Understand the risks associated with each storage method and choose the most appropriate one for your application's security requirements. Always implement security best practices to protect your application and data. Consider using established libraries and frameworks for authentication and authorization to reduce the risk of introducing vulnerabilities. Stay up to date with the latest security threats and vulnerabilities. This tutorial provides a solid foundation for securing your React applications with JWTs. Remember to adapt the code examples to your specific needs and to prioritize security in every aspect of your development process. Good luck.